The first scenario that we are going to demonstrate today is radio receiver multicast operation. So this slide shows my setup in the lab here. I'm running two CWPs, one on the 1.59, the other one is on the 1.85, and I'm running a radio at 12.2 on 2. So all these three nodes are connected to a connected through a IP router that supports this multicasting capability, and the multicast IP address is 232.1.1. So basically all the multicast functionality will be handled by this multicast router. So CWPs which want to participate in the multicast operation will send an invite with the multicast IP address included in the SDP body. So if the radio supports the multicast operation, then it is going to send 200 OK with that same multicast IP address. So as soon as the session is established, CWP will send IGMP request to this multicast router showing the interest to participate in the multicast session, and all the other CWPs will also send the request, IGMP request, to the multicast router. And the multicast router is internally, it is going to maintain a table, and it will have all the IP addresses which wants to receive the multicast traffic. So basically here the upstream direction which is used for which is from CWP to the GRS will be unicast only. Only the downstream direction will be multicasted. So basically GRS is going to maintain only one single stream for all its to convey the traffic to all the CWPs. So it is just going to send one copy of all the RTP and R2S packets to the IP router. The IP router, as soon as it receives the packet, it will send those packets to all the IP addresses registered in the routing table to all the individual CWPs. So advantage of this mechanism is like the radio will avoid the burden of maintaining multiple unicast sessions to the individual CWPs, and it will also help in reducing the bandwidth by sending only one copy of a stream to the IP multicast router. I am using the remote desktop manager to control the two systems. In one system I'll be running the CWPs, in the other system I'll be running the GRS. Let's invoke the maps radio. So map supports both ED137B and C version, so user can make the selection under a protocol version when we are invoking the application, and he can also choose the node type he wants to emulate. Now go to profile editor here. Okay, I have created one radio profile here, and this is running on the IP address 12.212, and I have configured the receiver multicast operation as enabled on this radio. So let's go and start the testbed here. Let's go to the CWP end, invoke maps radio, select ED137C and node type as a CWP. Go to profile editor. You can see here I have configured two CWP profiles. First one is running on 1.59, second one is running on 1.85. And for both the CWPs I have configured the multicast operation as enabled, and the multicast IP address configured is 232.1.1.1. So this is the IP address to which radio is going to send all its downstream traffic. Now let's start the test bed. This is the call generation window. I am going to place the calls using CWP 1 and 2. Both the calls are established. Now in the invite message, I can show you the multicast IP address that is being conveyed to the radio. Let's go to the GRS end on the call reception window. Now I'll start doing the squelch here. So this squelch traffic, the downstream traffic, will be sent to the multicast IP address. So you can see here 1.59 is sending traffic. This is the upstream traffic, unicast upstream traffic from the first CWP. This is the second CWP, and this one is the multicast IP traffic that is coming. And you can see here, this is the squelch that is happening from the radio. Now we'll go back to the CWP end, and we'll try to play the incoming squelch on this CWPs.
Phone number. Kite flying is such fun. I do it all day.
So that is the squelch received on the first CWP. Now I will play the second CWP voice also.
65,000 pounds is a city salary. 0444
So this is how the multicast operation is achieved using the multicast router in the network. Now we will move on to the second scenario, that is cell call tone transmission. This mechanism helps an aircraft crew to be notified of incoming communications even when the aircraft's radio has been muted. Thus, crew members need not devote their attention to continuous radio listening. An individual aircraft has its own assigned cell call code. So the controller who wants to talk to a particular aircraft will send the cell call tone of that aircraft using the SIP info message. The GRS, on the other hand, will read this code and transmit an equivalent analog tone in the radio frequency channel. The code is received by any aircraft receiver monitoring the radio frequency. But whenever an aircraft receives a signal containing its own assigned cell call code, then it will alert the aircraft's crew by sounding a chime or activating a light, or even both. Now we will demonstrate the cell call tone transmission feature in ED137C. You can see here under CWP profile we have provided an option to configure the cell call tone. This is a 4-digit code that identifies a particular CWP. Similarly, at the GRS side, we have provided an option to enable or disable this cell call tone feature. If it is enabled, it will be indicated in the 200 OK message to the invite. And we have also provided an option to configure the tone duration for this cell call. Now we'll go and place the call now. Call is established now. Now you can see that in the 200 OK we have got an indication from the radio that it supports the cell call feature. Now to transmit the cell call tone, right click on the key PTT and click on the info cell call. So you can see here info message has been sent, and this info message indicates the tone that that needs to be transmitted at the radio side. Okay, and you can see here we have got the 200 OK response, and immediately there is an indication from the radio indicating that the cell tone transmission has started, and it is indicated by normal PTT on, and the PTT ID reserved for cell call tone is 63, and after 10 seconds which is the duration that is configured at the radio side, okay, it is sending the PTT off indication, indicating that the tone transmission is completed. This is one of important feature in the ED137C. Now we will move on to the third scenario. This is a disconnection mode. Earlier in ED137B, the radio used to disconnect all the active session whenever its frequency ID changes. Now ED137C provides an option to retain these sessions whenever the frequency changes. So basically CWP has to indicate to the radio to retain this connection by adding no frequency disconnection attribute in the SDP invite SDP body. So when the frequency changes, the radio will retain this connection, and it will send a notify message to the CWP informing the latest frequency ID, whatever the change updated frequency ID. Here I have configured two CWP profiles. On the first CWP, I have configured the disconnection mode as enabled, and on the second CWP, I have configured it as disabled. And at the GRS end, I have created one GRS with frequency ID 125.000 and the disconnection mode as enabled. Now we will place the calls from CWP end. Both the calls are established, and on the first invite, which has requested GRS to retain the connection, we can see here it has included no frequency disconnection attribute, and on the second CWP it does not include that attribute here. So, and you can see the notify messages here. It has updated indicated the current frequency ID of the radio, and it also indicates the current active sessions at the radio. Now we'll go to GRS and try to change the frequency. Made it as 125.001. Save the profile. Now go back to the CWP end. So you can see here the second call is terminated because of the reason change in radio frequency, and the first call is still retained. Okay, and you can see the updated notify from the radio, which will indicate the updated frequency ID and also the current active sessions at the radio. So this is how CWP can request radio to retain the connection even when the frequency ID is changed.